Hi everyone, in this video I am going to explain about the VHDL code for Johnson counter. So in the previous video we have started the discussion of this Johnson counter, and Johnson counter consisting of D flip-flops, and the output of every flip-flop is connected as the input of the next flip-flop, but the complemented output of the last stage flip-flop is connected as the input for the first flip-flop. Just that one pin, instead of taking Q, we have taken here Q bar, that makes the count to double of the regular interval. So previously ring counter counts n bit ring counter counts n number of clock pulses, but whereas n bit Johnson counter can count 2n number of clock pulses. So this is the Johnson counter. As I said, we are taking the complemented form as the input for the first flip flop, and clock is common, that's why it is a synchronous counter. And this is the sequence table where the sequence of information is changing bit by bit, right side shifting, and the last output of the flip flop complemented output is connected as the input for the first flip flop. And the sequence table says that it can count 8 number of clock pulses, 0 to 7, nothing but 8 number of clock pulses. Okay, that's why we can write it is 2n, very important. Okay, and the state diagram, this is the way of states are being changed. Now coming to the VHDL code for this Johnson counter, VHDL code for the Johnson counter. So we know the two important lines that we have to write whenever the VHDL program starts. So library IEEE, use IEEE dot std underscore logic underscore 1164 dot all. Use IEEE dot std underscore logic underscore 1164 dot all. Entity, we know entity and architecture, these are the two important parts of the VHDL code. Entity is the place where we declare the inputs and output ports, and architecture is the place where we describe completely the behavior of the hardware model. So entity Johnson counter, is port. So here we have to specify what are the inputs and outputs. We have clock reset in std underscore logic, q out std underscore logic underscore vector, because it is a vector consisting of 4 bit of information, 3 down to 0. End Johnson counter. Next, coming to the most important part of the VHDL code, which is nothing but an architecture where the behavior is completely described. Architecture, behavioral of Johnson counter is so we are taking one signal, which is the temporary signal temp std underscore logic underscore vector 3 down to 0, See here, it is a temporary signal. Initially we are making this temporary signal equal to 4 zeros. Begin. So process of reset comma clock process reset comma clock begin. See, this process statement should always be there when we are writing the behavioral model. We know very well there are three styles of VHDL code. In the beginning we have discussed this. There are three styles of VHDL code. One is behavioral model, structural model, and data flow model. In behavioral model we have to instantiate this if, else, process and everything. Okay, suppose if you don't have if, else and conditional statements. Conditional statement means when else with select, that can come under data flow modeling. And structural model we know very well. Structural model is nothing but directly we are writing on the structure, how many number of times that gates being used, how many number of times that particular module has been used. Okay, that many times we are instantiating the structure. So begin if reset is equal to 1. Reset equal to 1 means we are completely making the flip-flops to 0. Then temp is equal to 4 zeros. Else if rising edge of the clock, then see this particular line, else if rising edge of the clock, or we can also say that clock is equal to 1 and clock tick event and clock equal to 1, that also we can write. Or see, we can write like this, or clock is equal to clock tick event and clock is equal to 1. If clock tick event and clock is equal to 1, this also we can write. Then okay, the meaning of this one is clock tick event. An event has been occurred in the changes of the clock. Event is nothing but changing from 0 to 1 or 1 to 0. Event is nothing but changing either from 0 to 1 or from the 1 to 0. This particular change is nothing but event. Okay, this event, suppose if you are using a rising edge clock signal, then we can specify clock is equal to 1. If it is a falling edge signal, then we have to specify it is clock is equal to 0, clock tick event and clock equal to 0. Okay, so depending on the rising edge or falling edge of the clock signal, we are specifying whether it is clock equal to 0 or 1 along with clock tick event. Okay, so instead of that we can also simply say rising edge of the clock, then temp of 1 is equal to equal to means less than equal to temp of 0, temporary of 2 is equal to temp of 1, temp of 3 is equal to temp of 2, and temp of 4 is equal to not temp of 3, and if process Q is equal to obtained temporary signal and N behavioral. Okay, so this is the VHDL code for the Johnson counter. So what is happening here, the just data is keep on shifting, but the last data, which is the complement of the last input, last output. So that is connected at the input of the Q4, D4. Okay, thank you.